Hi everyone. The lesson for today is to figure out the derivative of tan x. Now before we get started on the derivative of tan x, we'll have a very brief recap on some prior knowledge. You'll remember, of course, the unit circle, a circle centered at the origin with a radius of 1. The unit circle, we have a point P of coordinate x and y that traces around the circle, and the radius, the angle between the radius and the x-axis is our angle of interest, theta. Clearly this makes a right triangle with a base of x and a height of y and a hypotenuse of 1. From the triangle definitions, we would say cosine equals x over 1, or just x, sine equals y, and tan, being y over x, could also be expressed as sine over cosine. So that's the bit, tan equals sine over cosine, that we'll start with. While we're here, let's also review the Pythagoras identity. X squared plus y squared would equal 1 squared, or just 1. Given that x is cosine and y is the same as sine, we have this form. This is called the Pythagorean identity. So cosine squared theta plus sine squared theta equals 1. We'll need both of these ideas. Now let's go back. Now they were from back in Unit 2. So let's go back. And before we find the derivative of this, let's write this as sine x over cosine x. Now, that's looking like something we know, because previously we've seen how to do derivatives of sine and cosine. And we would write this as a quotient, u divided by v. U is the replacement for sine of x. V is the replacement for cosine of x. The derivative, u dashed, derivative of sine, is cosine of x. We saw that last time. And v dashed, the derivative of cosine, is the negative sine of x. So we're ready now for our quotient rule. dy dx, the derivative of, well, the original function really, dy dx, the derivative of tan. Now our quotient rule, remember, it's u times v minus u times v divided by v squared. Now we put a dash on the first one and a dash on the last one. Very important that we get those the right way round. So let's begin. U dashed is the cosine of x multiplied by v, which is also the cosine of x. Subtract u is the sine of x multiplied by v dashed, which is negative sine of x, all divided by v squared. V was the cosine of x, and we normally would write that as cos squared x. Now let's make all this a bit neater. Cos squared x plus sine squared x over cos squared x. That's the negative by the negative became the positive. I think we can see that the numerator is the Pythagorean identity. So this is 1 over cosine squared x. That's the derivative of tan. Now, we could have taken a slightly alternative path from here. We could have gone, let's split this as two fractions, cos squared divided by cos squared plus sine squared x divided by cos squared x. Well, that's 1, and if I think of this not as a sine squared over a cos squared, but if I think of this as a sine divided by a cos and the whole thing is squared, then I hope we can see that that's equivalent to tan squared x. So there are two different answers for the derivative. dy dx, that is the derivative of tan x, can be expressed as 1 over the cosine squared of x. Equally well, dy dx, the derivative of tan, can be expressed as 1 plus the tan squared of x. There's not right or wrong, they're both just as good as each other, and which one you choose, well, that's really up to you. Now, I want to finish with a quick demonstration. So let's go, first of all, I've got y equals tan of x here drawn. That's the tan function. We've seen that before. I'm going to use options, calculus, derivative of, now f1 gives me y variable number 1, and I'll press x so that it draws the derivative over the whole domain. This is the calculator, let me just move up a bit to see that a bit better. This is the calculator automatically determining the derivative function for us. That's nice. Now I'm going to type in this and see if it matches. And the calculator doesn't have the facility to put cos squared like this, I don't think. So I'm going to put cosine of x in brackets, then square it. I should mention that I'm in radians, and this only works in radians. If you're working in degrees, you have to take a few extra steps. There's that green function that I plotted, 1 over cos squared, exactly matches the automatic derivative that was generated. Now I'm going to go and try the alternate version. 1 plus the tan of x squared, tan squared x. Let's draw this. And the green one exactly matches once again. So I hope that's a convincing demonstration using using first of all my quotient rule and a few of my ideas from trigonometry back in Unit 2. That's should have convinced you. The technology, that's just the extra little bonus. And it's always handy when you're doing your own derivative questions. If you want to check if your answer is right, you can use your calculator in the way I just showed you. Okay, that's enough for now. Thanks for watching.